we have any questions? I have a question right now for both Simon as well as Jim and Fang. So, interesting, your two presentations today. You guys both kind of covered the gamut of, where we're going in buildings and a lot of things maybe we need to look at. But my question is, right now, if you look at what we do in high-rise buildings, super tall buildings, we have fire resistance, we have compartmentation, we have smoke detection, we have fire alarm, warning, and notification systems. We have buildings that could withstand very strong fires. We have elevators. Jim and Fang, in your presentation, you talked about the provisions of refuge areas and occupant evacuation elevators. So maybe you both could comment, maybe Simon, you first. If you look at that whole array of things we're doing, are there things we're doing right in that list of features? Are there things we're doing wrong? Where do we need to improve? So maybe you could comment about that a little bit.
Okay, I'll have a go at that. I think we have a very strong toolkit, and we have a very strong toolkit made of provisions and design solutions which have stood the test of time. Certainly, detection as a fundamental principle, the use of automatic fire suppression as fundamental principles. All these things are good standard components. The problem is we tend to sometimes trade off between these different things, and I think some of the new typologies, some of the change in building types and mixed uses and such like, that some of the traditional trade-offs we've looked at previously may need to be challenged. And I think we're also lagging a bit in terms of our understanding of some of the up-and-coming construction technologies as well. We're pretty good on steel and concrete. Is timber emerging as a high-rise construction material? Certainly the timber industry wanted to be a high-rise construction material, but we still lack a bit in terms of our understanding of timber as a high-rise construction material in fire. So I think that's what we probably need to improve most, is our understanding of some of the construction technologies. And we certainly have the good tools to fix most things, but it's just about using those tools correctly.
Jim or Fang?
Yeah, I think Simon's right. I think we have a really good toolbox of things that we can use, strategies that we can use in a fire safety design. I think the one area that we've seen of late that concerns us a little bit is sort of the overdoing stair pressurization and hoistway pressurization, and you have all of these mechanical systems, and then you have exhaust, and you have all these mechanical systems that are required by different provisions of the code, but just how those systems actually work together, we have to take a very close look at. You have stairs that are being pressurized, you have a floor that might be exhausted, you have all these things that interact with each other, and I think that's an area where we need to do a little bit of further work, both on the code side but also on the practice side, just to be sure that these things, in reality, that they're actually working in concert, that they're not working against each other. That's one of the areas I think we've seen of late in the last few projects, that we really are mindful of those issues.
Just add a bit to agree with that, and also just note that, interestingly enough, those sorts of problems, in the same way that the construction material issues, they weren't new in the 60s and 70s. People, when people first started looking at things like pressurization systems and different ventilation solutions, they actually worried about those air movement challenges and the way systems interacted. What I think has kind of happened over the years is that people have come perhaps a little bit, they've got used to some of the solutions, they kind of assume they work, they put them in, they don't take the effort to do the level of design and research that is actually required to be sure that that is the right solution. And I think it's always a good fun trick as a fire consultant to come up with buildings which meet code, which are unsafe, and you can demonstrate are unsafe. And I think we're starting to see with some of the new building types that are emerging it being very, very easy, too easy to design unsafe buildings that meet code.
Seems to me that there are many components in a super tall building or a mega tall building. You can sectionalize it. Stairs, floors, everything. But one component is more difficult is elevator hoistway, especially the fire lift that have to go up to all the floors. I think Jim, you kind of touch on it, of some people want to pressurize the elevator hoistway. I want to see, is there a feel or a comment from the panel here? Do you guys recommend pressurizing the hoistway of a 150-story tall shaft?
What we've seen more common lately is actually just pressurizing the firefighter's lobby, and either just doing the fire floor or doing maybe one above and one below, and just pressurize the lobby as a means of managing smoke movement in that particular shaft than the hoistway itself.
Hello. My question to the panel is, you spoke briefly about the refuge floor as a concept for evacuation. Now, we do know that in many parts of the world, the concept towards refuge floors are different. In some, for instance, as I'm aware, the US doesn't use refuge floors, whereas China does, and other parts where I come from, India, we do have a very strong refuge floor concept. Could you please elaborate a bit on the, if I may say so, the merits and demerits or the arguments for having a refuge floor or not? And secondly, as the buildings grow more and more taller, we move towards the supercritical areas, what are the new ways we are looking at towards evacuating such buildings? We talk about lifeboat elevators, we talk about all the other things that you've been talking about. So where do refuge floors stand in there? And if the buildings are going above 600, moving on to 800, as the number of habitable floors keep increasing, what other thinking is there currently on evacuating such some groups of people from such immensely tall structures?
My personal view on refuge floors is that I think they can respond to a relatively limited number of fire scenarios, and I think where they are included in buildings, there tends to be an over-reliance on them. I've certainly seen that in India. What I would prefer to see is the kind of approach that Jim and Fang pointed out for this sort of building, where you've got a much more use of distributed refuge spaces, where it gives you a lot more opportunity to respond to a lot of different fire scenarios, a lot of different situations, rather than trying to drive everybody into one space where they're expected to sit and wait and be rescued, for example. So I think there's more of a future in recognizing how we can turn existing space within a building into a defending place or a refuge space, rather than necessarily creating dedicated refuge floor spaces.
Yeah, just to help that gentleman out too, you might want to see a paper that was spurred by discussions in the CTBUH Fire and Safety Working Group on refuge floors, because there are both quite a bit of negatives as well as some, I think, some positives to refuge floors. But there's a paper from the last conference in Shanghai that you might be interested in reading that kind of covers that in some detail, and we hope to have a little more definitive guidance on all that maybe next year too for your, okay?
If you draw in the lines apex and opex, are you using a beam for that time to determine the left or right, or for the future for the beam? Because this point, this crossing maybe can be moved to the left if you use IPD.
That is just a figurative. I wouldn't say that was necessarily correct when you're applying it to a project. It's just a diagram for illustrative purposes. But it's certainly my experience, having been involved in several significant project teams. I was involved in the construction of Terminal 5 at Heathrow, that the project team were totally CapEx focused. And they were being driven by CapEx. And I saw it as my mission to try and say to them, have you considered whole life costings for the investment that we're doing in it? Because we were debating whether to fit sprinklers or not. We were debating whether to fit firefighting lifts inside the building. It was only by making the argument that you have to look at the lifetime cost that we were able to get those facilities, justify putting those facilities in. So I agree that where those lines cross, the CapEx and OpEx lines may move up and down that spectrum, but it's more for illustration to try and get project teams away from being totally CapEx focused. And value engineering is the term that we would use, which is basically, and fire and safety are the soft underbelly of any project, and they get cut and sliced and diminished. So as a fire engineer, I'm constantly having to defend that.
I just wanted to follow up on that, Russ. How do you have some thoughts or criteria in mind? You know, you say the more you spend, you know, you think you'll get it back, but, you know, how do you go about carefully, in your mind, trying to analyze where you should spend your fire protection dollars?
Well, if this is actually linked to the insurance question, and if you're looking at business, and if we can just, I know this may be slightly controversial, but if we can just park the life safety question for one moment. If we look at a business or a tall building, and you were to say that actually a foreseeable fire could probably make that building not viable for 2 years to be repaired, then that is quite compelling to the people that care about money. And as far as fire systems are concerned, I would be looking to make that building so resilient that it would attract the best premium. If you look at Factory Mutual, FM Global, they have a fully protected status that I'm sure you're familiar with. And that's where you can have the building that is so well spec'd and high levels of equipment. The missing thing for me is the management piece that goes with it, because you can have the best equipped, best spec building in the world. And as I discovered the other day, I went to a major building, fully sprinkled. It had a fantastic detection system in it. The sprinkler valve was shut, and it had been shut for some time. And they had no, so going back to your question, I think we have to use all the tools in the toolbox that Simon alluded to earlier on. And that must equal the risk appetite of the organisation, not just for life safety, but for the continuity of what they're trying to do.
And I have this question about, I'm thinking about the international building codes and the way they classify occupancies. And this, I think this addresses Russ. Do you believe that the international building codes, which I believe have a fairly simplified classification of occupancies, do they lack a component that addresses well, whether it's social housing or luxury apartment, because it's all classified as a residential occupancy. But in my mind, if you do build a residential building, that one of the most common forms to do that in Sweden today is eventually the house is going to be owned by the people who live there. And then I'm also thinking about the management issue. So do these international building codes address the actual type of lease, etc., in a good way?
My response to that is two things. I mean, if we look at assembly type loading, and typically that's going to be calculated on things like floor space factors, so we can come up with these occupancy numbers. In my experience, whilst that's a useful reference, it's not very helpful, because how do you know when the building's fully loaded? How do you know how many people are in there? I've had to look after several buildings where, for one reason or another, the occupancy limit has been massively exceeded. So what do you do about that? Because it does happen occasionally. Just take an airport. If you get a weather issue, then the airport fills up very quickly, and I've had to deal with that in the past. I think looking to the future, I think we need using smart systems and smartphones, and we can actually know the people loading inside a building, and then adjust your management response accordingly. I think that's the smart way forward. In terms of social housing, where you have people in their own flats, condominiums, whatever else it may be, there is a very sensitive issue here to be resolved, because we have some buildings in the UK and London which are social housing, where you have buildings that, or areas that are designed for a maximum of 4 people, where we're having 20 people residing in there. That comes down to right of access and trying to get across to people that that represents is dangerous behaviour, and it represents an excessive loading. but that's a political issue. It's very difficult as fire engineers. You know, you try and make it social housing, if you want to make it fire rated and you put passive barriers in there, etc. But if people want to live 20 to a flat designed for 4 people, that's a very difficult issue to address.
I did have a question for Al, and then we'll come back over here to Bill. Al, you know, you put up the UO263 tests, and I'm just wondering, in my mind, and maybe others in the audience, you know, you have the 9-foot column and the 12-foot beams. Could you maybe explain a little bit about how does that test work to extrapolate that to beam and column sizes that are far exceed those dimensions?
Well, again, these are dimensions that are commonly found in buildings. So 9-foot beam then would be for a regular story, a 10-foot story. The floor dimensions themselves, again, by 12-foot sections, we're able to extrapolate that in factors of, you know, common building sizes, 4 feet in the U.S. Again, looking at U.S. dimensions.
Okay.
And that's into 12-foot and in the beam span.
Hi, this is for the whole panel, just like your opinion. On a lot of tall buildings, the engineering and design end up, you have these floors with areas of refuge. And I don't know if there's any statistical data that's been pulled together that these areas have actually had to go into use during an event, like a fire or something. And some of you touched on this earlier about human behavior and panic. And is there any concern, if there's no data, that these floors will actually be, these areas of refuge will actually be used, that people actually know to go there and wait? Or will they panic and try and run down the stairs of a tall building?
That, to some extent, there was a little discussion on this in the previous session as well, where we were talking about areas of refuge, and there are challenges about whether they'll actually be used, and if they're not used and they're not properly looked after, that people will use them for something else. Storage being the classic situation. I've seen buildings with refuge floors that have been turned into plant rooms, and generally just abused. So I think there is a big challenge there, that if there's no practical benefit. I always say with fire safety solutions, if it's a fire safety solution that's got to sit there and not contribute to the building, then the building will find a way of using that space or using that system, or the system won't function, because fires are pretty rare events, and the way the building works is that its day-to-day occupational needs will override those factors. One of the points that was discussed, and Jim can talk about this a bit more, is that certain buildings like this building tend to look at a distributed refuge system where you're looking to find ways of lost space that's already been lost for lift lobbies and things like that, turning that into refuge solutions.
Yeah, that's really the way the U.S. codes deal with this idea of refuge floors, is that every floor is a refuge floor, right? So when you evacuate the fire floor, you evacuate them 3 floors down, and that's a refuge area for them. But this idea of refuge floors has just become a reality in so many locations, you know, that it does get included in a lot of the designs. You know, I think you have to be creative about it. We've used sky lobbies. Sky lobbies are great refuge floors, as long as you can manage the combustibles and that sort of thing, because that's the place that people normally wait for the shuttle elevators, or they wait, you know, it's a natural sort of waiting point. So they're a reality of most of the projects that we're seeing these days.
I'm Ankur. Basically, I come from a very high-density city. I come from India. Today, you know, in the developed countries, we talk about super tall, mega tall buildings. India is still poised on this. Basically, we have an average height, you know, not going more than 30 stories. But we do have a challenge in future where we are, you know, government is trying hard to accommodate high influx in urban centers and accommodate density. How do you see as a new typology which can actually have a connections, like if I talk about sky bridges as an evacuation strategy, rather than a tall building which is actually used only by few, not by the density thing actually. So what I see is mainly, a super tall or a mega tall may not be the solution for a developing country where the economy is a struggle. But if I'm looking at more of a tall buildings, which can, come up with a statistics which can tell us that okay, this particular parcel of land can accommodate this density of people, and the evacuation strategies may not be only with the high-speed lifts, or it could also be connected buildings. So how do you see sky bridges? For example, if I have to quote an example over here in modern buildings, one of the best example is the Petronas Towers, where they have the sky bridge, where they actually worked out a high efficiency flow plate because they got rid of the staircases. So do you see any future in the sky bridges as an evacuation strategy instead of a tall, super tall, mega tall buildings, for a high density living?
Yeah, I mean, absolutely. Where we have that opportunity to connect buildings like Petronas, we absolutely would take advantage of that for egress. Yeah, I mean, that's a good example, but we don't always have those. But where we do, yeah, absolutely. We do use sky bridges.
Yeah, just to add to that, I think that if we're looking at tall in terms of 30 floors or less for social housing, which is going to be high density, I think it's absolutely appropriate to have some kind of linking between the buildings. I think progressive horizontal evacuation, where it's available, is a great form of risk mitigation, and it should be looked at. So I think absolutely, I think it is a simple, I wouldn't say low cost, but it makes complete sense to me to have that as an option and have that available, and city planners should bear it in mind. It's got obviously issues of people migrating from building to building, but I don't say that that's easily overcome. I would strongly support that for certain types of high density housing, which I think it would give people the option, bearing in mind my comments earlier on about the denial of fire brigade response, fire service response in some of these areas, because there's a whole host of reasons why the fire service may not respond to be in that area, and I think it's completely appropriate.
Ervin, I did have a question for you as a follow-up. I mean, there was, on your smoke control analysis that you put up there, I'm just trying to clarify maybe for the audience, you had a calculation of 1,000 cubic meters per second for trying to deal with the smoke in that atrium space. Could you just explain that a little bit more, because I think some folks maybe didn't understand what the issue was there.
Oh, the 1,000 cubic meter per second is the exhaust rate calculated based using the empirical equation based on the assumption that a clear smoke layer can be maintained 6 feet or 1.8 meters above the top floor. But actually, it's since the strong turbulence created by the large exhaust, it's really hard to maintain that kind of a smoke layer, clear smoke layer. So the smoke actually is all over the atrium, but it's much diluted. And
this is not a question. This is I'm quite to have your opinion. We have a situation lately that for so many years, our reference in Jakarta for fire regulation is mostly using NFPA. Right? I myself, 25 years ago, in university, trained and studied by NFPA. But recently, starting in 2008, we have the Jakarta Authority. They released a new regulation. It's not the reference to NFPA, but I think it's reference to a British code. This is what I really want to have your opinion. Now we have a standard for every 900. We talk about tall building. A footprint of 900. Every 900 square meter needs one compartment, a fire compartment. Fire compartment's definition is consists of 3 elements: one fire stairs, one fire compartment, one fire lobby, and one fire stairs itself. So that regulation is really reducing the semi-gross. Yeah, so most of developer really against that. Yeah, so we are the position in the middle. Yeah, and we have to fulfill all the regulation, but our market in Jakarta is really against that regulation actually. Yeah, and also for the basement. Yeah, for the basement, it's every 1,500 square meter area needs one. So it means it's 4,000. Yeah, we require 3. Yeah, it's something like that. Yeah. Is it comply also in Britain? That kind of regulation, or there is too much additional regulation comply by our government? Yeah, something like that. Just your opinion to all. Thank you.
I would say that's a pretty bad misinterpretation of anything from a British code. Plus, the way it works in Britain, in the same way it works in most international codes now, there isn't such a thing really as code compliance by following a particular set of design rules. That might be a starting point. That might imply that there are certain issues to be addressed, but you really should be looking at what are the risks being addressed, and setting fixed limits on things like compartment sizes, particularly for basements. I mean, you think Jakarta's got a problem with 1,500 square meters, go and do a project in Mumbai, where the starting point is a 500 square meter compartment. Then try and do that in a car park that's got 70,000 car parking spaces in it and see how many fire compartments you get. It's crazy. And I'm seeing that applied rigidly by, not so much by the fire officials, but by designers sometimes who don't understand the power of using a performance-based approach. And the things, in some cases, things like car parks and basements, for example, sometimes bigger is actually better. You know, in a car park, the risk is not proportional to the size of the compartment. The car park fire risk is the same whether it's a car park that's got 10 cars in it or 10,000 cars in it. Roughly the same number of cars set on fire at any time. So the bigger volume actually gives you a lot more dilution and allows you to move away from the space. So those sorts of limits would certainly not be applied in the UK, and could certainly be worked around. It might imply that there's a concern that people haven't got enough exits available or something like that, but that's a matter of just working through the calculations and demonstrating that it's safe.
What I would urge you is that codes and standards and guidance are generic documents, and they do their best to try and cater for as many buildings as they possibly can. When we're talking about these buildings, they are singular type challenges, and anybody that sticks rigidly to any codes and standards in this is making a massive mistake, and they're not always right. We've got ourselves into a situation in the UK with one particular new standard where we can now build residential, very tall buildings with one staircase only. And we have just opened the first one in London. It's 50 St George's Tower, 52 floors. It's got one staircase in it. Now, the applied logic there is that staircase is protected, it's pressurized, et cetera, et cetera, et cetera. I personally don't think that's right, whereas some of my colleagues in fire engineers, they're completely happy with it. So I think the abiding principle there is that when we're talking about these extraordinary buildings, which they are, to stick rigidly to any code or guidance is a mistake. And the other fear I have is when people cherry pick from standards, and they go to several different standards to get the answer that they want. So they have a bit of NFPA, they have a bit of a DIN standard, they have a bit of a British standard, they have a bit of Eurocode, and you end up with this patchwork quilt of standards to try and make something work, and it's wrong.
Just add one little point to that. Russ is absolutely right that cherry picking of codes and stuff like that, but it links back to the question about occupancies earlier as well. Whilst occupancy types are used within standard codes to help guide people on what typical risks might be, in fact, all the big international codes, British codes, Australian codes, the American codes, they all have bits at the front that say, these are guidelines, you need to make sure that the risks you're dealing with match the solutions and that you take the risks into account. And so many people pick up codes, they go straight to the technical bits and start saying we need to do this, this and this, or with this type of occupancy. Whereas if you know you've got a different risk from social housing, or we have a big issue with changing demographic with more elderly people, with larger family groups living in high-rise buildings, if you're not taking that into account, then technically in the UK you'd be breaking the law. You wouldn't be providing a compliant building. And that's where performance-based design puts the power into the approver's hands, because it's the onus then on the designer to demonstrate they've taken the risks into account and they've come up with a solution. Now, it cuts both ways, because often that gives you a more efficient solution, or a solution that is better suited to the overall operation of the building. But fire engineering and performance solutions are not all about cutting stuff out of buildings. It's about making it fit for purpose. And that cuts both ways. I say, if you know you've got something that's different for your occupancy type, then you've really got to take that into account. And in the same way that if you think your risk is lower and you don't need a 900 square metre compartment, you should be able to take that into account as well. It's cuts both ways.
Yeah, and then this issue of car park compartments and travel distance and all of that, we have seen a lot of fire engineered solutions, performance-based design solutions to address a lot of those issues, because they, especially coming from the U.S. codes, they just don't make any sense to us whatsoever. Our travel distances are 3 times what the travel distances are in some of these codes, and no compartmentation. Now maybe that's too far, but there is a reasonable, logical solution that's somewhere between those two ends of the spectrum.
I want to go back to the issue of resiliency. I think, Ross, you mentioned maybe a couple times that the fire department may not show up. So it's interesting that in the China Code, the new one that's going to come out next May, the fire pump and the firefighting devices has to be located in B1 level, which is better than B3 or B4. To the panel, do you have any recommendation, suggestion on should the fire protection equipment locate into a criteria? For example, is it the 100-year flood line? What is it that, and should it be governed by code to do that regarding the resiliency issue?
I can tell you what they're doing in New York. I'm seeing a lot of diesel tanks being moved up to the roof. Now, I'm not happy with that. I don't think moving diesel tanks onto the roof, a week's supply of diesel on the roof, is a good idea any time. Certainly, I would be looking for those facilities that are critical to the fire strategy of the building, if they're electrically operated and supported by standby generators, that they would be somewhere between the 2nd and the 4th floor. Now, I know that's not going to be popular with anybody, but that's the reality check about where you want the risk of having a diesel tank spill or split, or pipelines running through the building supplying generators. Where you draw that line, I think that's a good discussion to have with your insurers, rather than the fire department, because all they want is the equipment to work if they turn up. And you have to take into account the prevailing 1 in 100-year event, be it flooding, riverbanks, etc., whatever else that may be. But certainly what Hurricane Sandy has taught us is that if you have all of your equipment in the basement and you're at all at risk of being flooded, you've got a big problem.
The other thing to think about there is that we mustn't think about tall buildings in isolation, and you've got to then think also about your whole urban emergency planning. One of the premises that we tend to work to is that, well, if you're going to have that kind of event, the chances are the building wouldn't be open anyway, because they would have warned people and people wouldn't be using the building. That's great, except that if your emergency planning is in place to absolutely clear those buildings, then you still use the buildings. And when you've got financial sectors and people who think they can still run their buildings when there's going to be flooding, who then suddenly find a situation that Russ was talking about, where those generators suddenly get flooded, you have people who think they're resilient but actually aren't, and that's a really dangerous situation.
Question for Simon Lay and Russ in particular. Concerned about building management as generally being the orphan in fire control. And an example I want to give is the issue of governance in, for example, London, where we have a failure to control the increasing fire risk due to the mushrooming social problems of rental housing, where buildings are being massively subdivided with increased fire loads, while people are using government subsidy money for their rent in an improved way. Now, the fire regulations have actually come from the UK 120 years ago. This to me sounds like an absolute failure. Now the concern is super tall buildings are going to be another example of housing infrastructure in the future. We must have governance that's going to match this challenge, surely.
I think you're absolutely right that one of the big challenges we face at the moment is the way that people are almost abusing the spaces that they're in. I saw a very good presentation by the Assistant Chief Commissioner, Fire Chief Commissioner for London in Singapore last week, and she was talking about the challenges of facing that and what the fire service can do about that, because the place where people die in fires is still in their own homes, and we have very little power legally to do much about stopping people from doing that, apart from where it's rented. And where it is rented, there is power there to go in and place requirements on landlords, but that then requires a commitment by the local authorities to enforce those measures. And we have the power and we have the tools to do that. The problem we have is that people kind of turn not so much a blind eye to it, but until we have a serious incident, I don't think it will hit the headlines enough for people to want to do it. That the local authorities have other things that they feel they want to spend their money on, and until there's a disaster, I don't think they will actually, unfortunately, step up to the plate. Now, the thing is, we can talk about that. You can bring that issue up. I know it exists. I'm sure Russ knows it exists. The London Fire Brigade know it exists. Now, the London Fire Brigade are part of the approval process, so they should be challenging people who are designing housing, particularly where it's of a type or a location where it's likely to end up being used in a social housing circumstances, and they should be asking people to take that sort of stuff into account. Not relying on protected entrance hallways designed into apartments because people will take the doors down, not making assumptions like 1 megawatt fires in unsprinkled residential buildings and stuff like that, just because some 20-year-old book said that might be appropriate. Stuff like that needs to go out the window. People need to be forced through the approval process to say, well, what if we have an over-occupation? The classic example, the single staircase residential design we have in the UK, and to some extent Australia does allow, that is predicated on the fact that people do not try to evacuate, okay? Because you completely lose the core as a result of the firefighting activities. We now have a situation whereby you may have people who come from different cultures where panic may be perhaps perceived to be, and there seems to be some evidence that the panic is more prevalent. You have the sort of post-9/11 effect of people not wanting to stay in a building when it's on fire. So we should be challenging the fact that, well, just because the code assumes people stay where they are, is achieving something that's as good as the code the right thing to do? If the code is wrong, then we need to be achieving better than code. So we should be saying you should assume that people are safe if they stay where they are, and actually they should also be safe if they decide to evacuate. And that's a very, very difficult scenario to design to. And as soon as you introduce that requirement as a performance-based requirement, it changes everything from your structural fire protection solutions, your smoke control solutions, all change radically. But there are situations where we've been asked to do that, where the authorities have asked and the fire engineering community steps up to the plate. Unfortunately, there's a lot of social housing where they don't engage with fire and life safety engineers. The architect draws it, they think it's simple, it's a 10 or 15-story building, we know what we're doing, we take the plans, we draw it, we extrapolate it, bingo, job done. But the right questions aren't being asked, I think, and that is probably the shortcut to help and control that.
I think mine is really simple. I think if you're at the bottom end of the social spectrum, and I think we have, it doesn't matter where you come from in the world, if you're in that place, it's not a great place, and it's a basic human right that you should have a safe place to live. We are in a difficult situation here where if you're in your own home, be it rented, if it's a local authority property, you're entitled to quiet contentment, and you don't want people banging on the door coming into your flat. Unfortunately, if we're going to put people into high-rise buildings, and there's going to be lots of them in there, it only takes one person to have unsafe behaviour, and you saw the kind of hoarding that I was looking at earlier on. That's quite a common issue now that we're finding within these flats. It's a very delicate issue, but I would make this one point. Quite a lot of this social housing, and this goes around the world, is not sprinkled. And why isn't it sprinkled? Because it's built on a budget, because people know that the people at the bottom end of the pile are going to be put in that building, and of course they've got no leverage to get it sprinkled. the kind of business buildings that we're residing in now will always be top specification. It's a hugely contentious issue, but I think that only now in the UK are we starting to say for the social housing where we're putting people who are at the bottom of the pile, we're now actively talking about retrofitting sprinklers inside building, and I think that's the only way forward.